Yeah, hello everyone. Um, Welcome to today's session. Please confirm you can hear me. Please confirm you can hear me and you can see my screen. Please confirm you can hear me and you can see my screen. Okay, I think oh, sorry, I muted you guys. Oh, sorry. Yeah. Okay, great. Yep. Sorry about that. I didn't want a distraction, so I did automatic muting. But I think Victor, you can unmute yourself. I made you a co-host. Victor?
All right. Yeah, I'm here. I'm here, Dr. Felix.
Yeah, very good. Okay,
Mm,
very good. Yeah.
Thank you.
Yeah. Uh, so I don't know, did you have you join the session as sorry, I have to paste it to you. Try and fill the survey if you have not filled it, because this is one of the conditions for your certifications, because that's the only way I can tell if you joined the session or not. So please just try. So I'm putting it again in the chat. So Victor, occasionally you can drop this as more people come in and encourage them to fill the survey. All right, so I think we can actually start. So I know that, yeah, you are already familiar with the use of arrow. Why some other they are newbies in this session is to balance. Then sometimes it feels like if the fees you're paying is commensurate to what they are being taught, because sometimes you see these things and you feel like, maybe I can actually teach them these things at home. You see, but what you fail to understand is that these people that are taking these kits, they are experts, okay? They are experts. So what that means is they know what they are actually doing. Now my boy is 6 and he can actually read very well. He reads almost everything. So you can see that even if it appears like the learning process was not at the pace that you wanted, but the school was able to achieve why you took him there, which is to read and write very well. So that's part of what I want to do here. I want to start Arrow from what they call the basic building blocks. You may not have seen it like this before, but I realized that a lot of times when people struggle with the use of Arrow, it's simply because this aspect was not, done. So you go into Arrow and you just started running with the advanced algorithms and the rest of them. And sometimes you write some things and you're not sure why you write them, because the foundation was not there. So I will try as much as possible to put you through these basic building blocks, then we will take it a step further into some data analytics process. And I hope this will really strengthen your use of Arrow. Now, you also have to appreciate that Arrow is not the only statistical software. There are other traditional statistical softwares that are out there. You know, we have the SPSS, we have the EpiInfo, we have SAS, we have Stata, and Python, you know, pandas can, you know, actually analyze data as well, you know, but we are focusing on Arrow for this particular, you know, session. So this is Arrow Studio, which I shared a video. When you install Arrow, you will now install the Arrow Studio. So when you install the Arrow Studio, you would have something like this. So this is what you are going to have for the Arrow Studio. So yeah, it said the voice is breaking. Is the voice still breaking? If it's still breaking, maybe I may have to stop
No,
this.
it's okay now. No, it's okay now.
It's okay now. Okay.
Yes, please.
All right. Okay. Thank you, Victor, for that update. So this is what the Arrow Studio looks like. If you had installed it, you will have 4 panels, 1 here, 2 here, 3 here, and 4 here. But if you don't have 4 panels, it means you have to do some drop down. Like, see, if I come to this part and I click this, you see what happens? It closes out there. If I click it, it comes down. If I come to this place and click here, the same thing happens. It goes down. If I click it, it comes up. So you see, sometimes when you have just 3 panels or 2 panels, it means you had not used the troll key, you know, so you can actually do that. But the original, you know, format it's supposed to be is this 4 pane, 1, 2, 3, 4. So what do they really do? In this first path, this is where you can write your script. If you go to File, if you do New, you will see what they call Arrow scripts. All right. So the Arrow script is this that you're seeing. This is where you can actually write your script. You highlight all the scripts, then you come here and run it. Then it's going to show here at the console down here. So whatever you run here, you're going to see it down here at the console. So this console serves 2 functions. You can write 1 line code each here in the console and use enter to run it. Okay, but if you are writing a code that is more than 1 line, it's better to write them in the script, then highlight all of them, then run it. Okay, but if you want to run 1 line at a time, then you can do that here and use enter. Then here is simply history. Any work you do in your Arrow script or any work you do in your console, you're going to see the history here. That is the function of the history. So if I open your Arrow, I can tell the things you have been doing. So if you look at my Arrow, these are the things I have been doing. All right. Then here, it can give you plots. When you run codes for plots, it will show the plots here. Also, if you ask some questions in Arrow to be able to understand what a function does, it will also appear here so that you can read about that function. So primarily, this is what these 4 panes they do. Okay, so if you want to install a package like I showed you in the video, you can come to tools here, you go to install packages, you can type the package and it will show, then you can install. But if you don't want to do it that way, then you can write the function which is install package. One of the good things about Arrow Studio, as you start typing whatever function you want, it will give you options. You see, then you can use your arrow key to go down or go up and choose which one you want. So if it's install packages, meaning a package you want to install now, you choose the first one. But if you want to confirm that you've installed a package before, you can use the second one. All right. So that is how these actually work. So let's go to our notes. Now, this notes that I've made is like a step by step. So I've minimized this so that you can actually see the note I have made. So I'm going to be sharing this note with you. I hope I am able to cover this note. So I don't want to do things haphazardly. That's why I created this note so that you can, especially those that are new in Arrow, so that you can actually flow with me step by step, and let's see how far we can go. So after this session, then you can ask your question. Now, this session is recorded. All right, it's recorded. Now, being recorded, yes, you will have access to the recording, and also you will have access to the lecture material after each day. Your certification is dependent on you filling that pre-survey, because that's where I'm going to get your name, your name the way you want it in the certification. All right. So I created this note so that we can take it step by step, especially for those that are new in Arrow. Okay. So please flow with me at this space. If you're an expert, please flow with me. As a newbie, please flow with me. All right. So the first thing you need to appreciate when it comes to Arrow is you can ask Arrow questions. There are so many packages in Arrow. It should be more than 10,000 right now. So when you install Arrow, it's empty, meaning that there's nothing in it. That's why you see the file is small. That's the beautiful thing about Arrow. If you want to install SPSS now, you'll be talking like, something really big, like 1 gigabyte or so. All right? Maybe more, depending on the version you want to install. But when it comes to Arrow, you will see that the file is small. The reason why they made the file small is so that you can just install the Arrow and install the Arrow Studio. But as you analyze your data, you begin to install the packages that you need for the purpose of that data analysis. So in other words, it may not be all the packages in Arrow that you may use in a lifetime. You only install the one that you need. I remember a few years ago when I want to do meta-analysis, I usually use a software called RevMan. I don't know if you've heard of it. It was manufactured by Cochrane. So I used to use RevMan for meta-analysis. All right. A meta-analysis is when you're doing a systematic review where you bring, original or primary articles together to synthesize them. But when you bring all the data from each of those primary studies or articles, you can actually analyze them. So they call that process meta-analysis, pooling of data to analyze. So RevMan does that very well. But recently, RevMan is not free anymore. You have to pay for it. But I found out that there is a package in Arrow that does meta-analysis very well. It's called Metaform. So if you go to Tools, Install Packages, and you type Metaform, you will see it. Metafor, yeah, sorry, Metafor. So I have been using Metafor for my meta-analysis, and the Forex plot, the funnel plot it gives you, they are very beautiful. So you can actually try it. All right. But that's by the way. So what I'm saying is you can ask Arrow, anything if you're not clear. Like somebody tells you, oh, you can use Metafor for meta-analysis. You can come here and you put a question mark before you put the package Metafor. Sorry, let me see this thing again. Meta. Okay, so let's say metaphor. I think it's FOR. So question mark metaphor, you press enter. So you see now, you see it. So it's telling you what that package is. Metaphor for meta-analysis package for Arrow. So you can read more about it and how you can use it. So that's how this question mark works. So anytime you want to know anything about a package you have not used before, somebody tells you about it, you can just come to Arrow. First, you have to put a question mark. Then you can put that package. Like there's a package they call concatenate, is small c. So you can do question mark and small c. And you can press enter. Arrow can tell you what that package is. It's concatenate. It is used to combine values in Arrow. We would use it, briefly here. You can find out what a vector is and many other things. So that's the first thing I wanted to show us, how to get help in Arrow. The second thing is you have to appreciate the fact that Arrow is case sensitive. Case sensitive, meaning that this full capital OO, capital F and small oo, and all small caps, they are different objects when it comes to Arrow. Like I mentioned to you now, we have a package called a function called C, which is concatenate, to combine. So imagine if I tell Arrow, please tell me about the concatenate, and I type capital C instead of small c. Let's see what is going to happen. You see. So the capital C is contrast for a factor. Capital C is not concatenate, which is why I said Arrow is case sensitive. So you have to know the function you want to use. Is it small letter or capital letter? You can also use Arrow for mathematical calculations. All right. So you would appreciate that. I am using the console now. Do you know why I'm using the console side? I'm not using the Arrow script side because most of the things I'm going to be showing you, they are one-line commands. So if you're going to be typing a one-line command, there's no need coming to the script. A script is when you're going to be writing 2 or 3 lines to run them together. We're going to do that as we progress. Now, Arrow can serve as a calculator. Like the example I gave here, if I say 5 plus 7 and I press my enter, it's going to give me 12. If I say 8 times 4, if I press enter, it's going to give me 32. So Arrow can serve as a calculator. Now, another thing I want to teach you, which is very important and you're going to be using all your life cycle as an Arrow programmer, is the assigning key. The assigning key is less than minus. That's an assigning key, meaning you can use it to assign any long code line you have written to one letter or a word so that you don't have to type that code line again. Let me give you an example. Now, I told you that Arrow, you can use it for calculation. What if I do 5 times 8 plus 9 plus 4 times 16 times 21 times 3? This is a very complex calculation. Now I'm going to press enter and see what it gives me. 4081. Now, what if I am programming and I've written a very long code like this? All right. And I need to be using that code line that generates 4081 often. Do I have to be typing 5 times 8 plus 9 plus 4 times 16 times 21 times 3 every time I want to use that code line. No, I don't have to. I can use the assigning key to assign that long calculation into one letter, so that anytime I type that letter, Arrow understands that it is that code line. That's what is called assigning key. Secondly, you don't have to type a long code line if you had typed it before. Arrow can return things. So let me see if I can get my virtual keyboard. Can you, I know you can see my virtual keyboard. All right, Victor.
Yes, we can see
Good.
it.
Now, in your virtual keyboard, you see this key. That's your up key. You can use this key to return long code lines you had written. You don't have to retype them every time. Let me show you an example. Now, I put my cursor here. I want to bring back, so instead of typing 5 times 8 plus 9 plus, I don't have to retype it again. So I can use this up and bring it back. You see it there now. Then I can now use this to take the cursor to the end and assign it to maybe small x. Then I put a space. Then small x is what I want to use. Sorry, not capital X. I put a space, less than. So this is the less than. So this is the less than. Sorry. Yeah. So this is the less than. Sorry, this is what I meant. The less than, then minus. Yeah. So that is it. So I have returned this long code. I have now assigned it to small x. The assigning is less than and minus. So all you do now is press enter. That's it. So what is x? You just type x, and press enter again. It will tell you what x is. So x is now 4081. So what does that mean? It means that anytime you type x, you mean 5 times 8 plus 9 plus 4 times 16 times 21 times 3. So you don't always have to be typing that long code every time. You can always assign something to a letter. Okay, so now that x is 4081. So what if I say x times 2? What would that be? That will now be 4081 times 2, because x is 4081. So I'm going to press enter now. You see, so it's now 8162. All right. So what if I now assign these? Instead of assigning it to x, I now assign it to y. It will erase what you had done before. That's how arrow works. So if you had assigned something to x and you now assign that thing to another alphabet, it erases what you had previously. So if I do this now and I press enter and I said, what is x? It's 4081. What is y? It's 4081. So what do? You now have to assign one to the other. Okay, so I can assign y to x. So if I say what is y, it gives me 4081. So I now have only y instead of having x and y, because I've now assigned x to y. So why I'm saying this is I'm using maths to actually show you this, but you are going to be using this in a real scenario. Okay, So that's why I said, let me show you now, so that when I start using it in analysis, you say, oh, is this what the assigning key does? You won't have to be guessing, why am I using less than and minus to assign? So let's move further to what they call vector. You probably would have heard of vector. There's no way you'll be doing programming or using arrow or Python, you will not hear of vector. So I wanted to introduce you to vector. Vector simply means small collection of numbers, numerical numbers, okay? But for you to effectively use those numbers, you have to concatenate them. You will see during analysis, we're going to be concatenating code lines. You will now appreciate why we have to concatenate them. If you don't concatenate that number, they would not be a collection of number. So meaning that you would not be able to use them as a collection of number. So for example, now, if I do like 1.1, 9, like I did here, and 3.14, and I press enter, it doesn't mean anything. It gives you error. Arrow doesn't see it as anything. So listing numbers in arrow without concatenating them will give you an error. You see? So, and when you concatenate those numbers, you have to assign it. So if I do concatenate now, and I do 1.1, and I do 9, then 3.14, like I've done in this example. And one of the things I should mention is that, which is beautiful about Arrow Studio, if you start with your arrow, if you start with your bracket open, by default, Arrow Studio will put a bracket closed for you. Because when you use arrow, which is, I feel arrow is for those that are really advanced in programming. So you would always remember. So when you use arrow and you do your bracket open, it doesn't do bracket close for you. And when you finish your script, your code script, and you don't close, it will not run. You will see an error, then you now have to come back again. But Arrow Studio does not allow that happen. All right. So you have your concatenate and you press enter. So it has given you 1.1, 9, and 3.14. Unlike the previous one where you didn't concatenate and it gives you an error. So 1.109 and 3.10, they are called collection of numbers. They are numbers, numbering collection. Okay, they are numbering collection. So you use the concatenates, all right, to actually make this happen. Okay, so we are going to be assigning these concatenate numbers we have done to another letter now, still in the assigning. So what if I do the concatenate again, but instead of repeating what I typed, I want to bring it back using the arrow key I showed you before up. Then I take my cursor to the end. I want to assign it to small letter Z. I use the assigning key and I do enter. It's not going to give me anything because I've assigned it to Z. But if I said, what is Z? What is Z? And I press enter, you see, it's going to tell me Z is 1.109 and 3.14. So you remember we had assigned 4,081 to Y. So what if I say Z times Y? What is going to happen? So you're going to have 1.10 times 4081, 9 times 4081, and 3.14 times 4081. Okay, so that's how the vector works with concatenate. It's just simply collection of numbers. Okay, now I've showed you that arrow can actually do mathematics. And for maths, you know, this is square roots. It's also a function in arrow. SQ arrow T is there. See, I typed the 3 letters is out. I can press enter to choose it. So square root of 25 is what? Enter. That's 5. So arrow can do maths. So that I'd already made that clear for you before. Okay, so let's I have these notes so you can actually go through them. This is like an exercise you can go through. So let's move to something else. Workspace and files plus function. This is very, very important, especially for those of us that will start to work with arrow. The way you do workspace and files and function is totally different in arrow. Totally different. For example, now, if I want to open a file, a regular file in my computer, what I would do is I will click on file like this. So this is the folder I'm using for this workshop. I can come to my documents and I can see my files and the rest of them, but it doesn't work like that in Arrow because Arrow is command line based. Arrow is command line based. So most of the things you do them through a function or through a package you have installed. So let's see how you work with files or how you navigate files in Arrow, because this is very important. Even before you start working on your data analysis in Arrow, you need to know your working directory. The files you're working with in Arrow, where are they saved? In a normal sense, if you are working with Windows and you want to save your file, you will just come to files here. You click on files, it will give you options. One of the options is save as. Then you can now choose where you want to save it, but that's not how Arrow works. So you have to write a function to know your working directory, meaning when you are saving your files, where do they go to? So that function is called getWD. The full name is get working directory, so that you can know where you are actually working in your computer. So you type your get, it gives you option, say it there. The first one, you can choose it by pressing enter. That's all you need. You don't need to do anything. You just type get working directory and you press enter. So for me, it's telling me that anything I'm doing is inside a folder in my documents. And that folder in my documents is inside another folder, HP. That folder in HP is inside another folder, users. That folder in users is inside my drive C. So this is my working directory. So in other words, everything I'm doing is going to go inside my documents. So now I know where to get my files if I need them. Now, the second thing you can do after you now know your working directory is to list the files in that working directory. You can list the files in that working directory by using another function called ls. All right, then brackets, then it closes it for you. List the object inside my working directory. That's all. You just press enter and it's going to list them. I have like 155. All right, but yours may be smaller, it may be more. So I have an idea, the things that are there. Okay. Now, the other thing that is another function that you can do, you can tell it to list the files that are there. The ls is list the objects that are there. Then list the files is a function that means list the files that are there. Now, the reason why I'm showing you all these is because as a programmer, you may not, I mean, when you become really good at programming, you may not need to be going to your folder to check things. That's the point. Because some of you will say, if I want to know the files that are in my computer now, I can just go to folder and I will know the files that are there. You get it? Yes, that is, like normal. But as a programmer, we use functions for everything. All right, I'm just teaching you, these things. Yeah, even if, yes, you can just do it in a shortcut, but you need to know as a programmer how these things are done. So as a programmer, if you want to know the files in your working directory, you don't go and look for the folder and click it. You can use a function to know that, and it's called list files. So if you type your list dot files, it will give you options. That's the first one. That's all you do. You just press enter and it's going to list all the files. So these are all the files in my working directory. Okay. So these are all the files in my working directory. Then another thing you can do is you can actually create files using a function. Now, if you want to create files normally, what do? It's easy. You come to your folder. If you want to create it in the documents, you just click your documents. Then what do? You right click. When you right click, you go to new. Then you go to folder, isn't it? Then you click on folder. Then you can now rename this folder to what you want to call it. That's how you create a folder. But if you're working with arrow, that's not how you create a folder. To create a folder, you use a function called directory create. All right, then you can create a folder inside your working directory, which is documents now. So let me show you how that is done. So I'll type dir arrow directory create dots. So it's there now, it's already showing me. Good. Now I want to create a folder inside my working directory, which is the documents. All right. What will I call the folder? Let me call it ACU arrow class. So I type capital AC, but you have to put it in quotation mark, like this example I've shown you here. So you have to start with quotation mark. So ACU arrow class, that's what I want to call the folder. Then I press enter. So it has created this folder. So let's find out. Although if I want to know if this folder is created, there's another way you can tell. But in a regular way, to confirm this, if you go to that folder, to the documents, all right, and scroll up, see it here. The folder is already created. But I didn't come here, right click, go to new, clicked folder and renamed it to ACU arrow class. No, that's not what I did. I used the function to create that folder. That's what you do when you're working with arrow. Okay. Now you have to appreciate the fact that initially when we did our working directory, I saw that my working directory is documents. So I don't want anything I'm doing in arrow to scatter all over. Oh, touches writing some things. How do I clean that up? Okay. Okay. Tochi, please stop writing on the screen. Tochi, please stop writing on the screen. Oh, there. Maybe her screen is acting up. Okay, all right. Okay, so let's progress. So my working directory was documents, and I don't want to be doing anything in Arrow, and all the things I'm doing are scattered in documents. So I've created a new directory now, which I called ACU Arrow class. And I want all the things I'm doing to go into this folder, not in my documents. So what do? I have to set my working directory to ACU Arrow class so that anything I'm doing subsequently will be saved in this folder here, this ACU Arrow class, not in my documents. So how do you do that? You do set your working directory. So what are you setting your working directory to? I'm setting my working directory to ACU Arrow class. That's what I want now to be my working directory, not the documents now. I've set it there. So let me confirm what my working directory will now be. So I now do get working directory. So that's it. So what is it now? You see, something has been added to my working directory that was not there before, which is the ACU Arrow class. So now my working directory is this folder, which is here now. So it means anything I'm doing now does not just go into the documents, but it goes into this folder here. So that's now my working directory. Now in that my working directory, I want to now create a file. So if you want to create a file in a normal sense, how do you do that? You just come here, do a Word document, and you open a file. So I've created a Word document file now. So this is it. Then if I want to save it, I can now go to File and go to Save As and choose where I want to save it. Okay? So that's what you would normally do. But when you're working with Arrow, we create files differently. All right? So I want to create a file now inside this my working directory. So I use a function, they call it file create. So I type file.create, so it's there. See it here, I choose it. Then the name of the file, I have to put it in quotation. Always remember that. Then what will I call the file now? Let me call it, let me still call it, let me just say, maybe the same ACU, but this time I'll put underscore. Let me say arrow files, if that's okay. All right, so let's call it ACU underscore arrow files. So I've created the file. So it said true. True means the file is already there. All right, so let's confirm manually if there's a file created in that folder. So we can go there and check this. So this is the folder. If you open it, you will see a file there. You see the file. But we can't use this file because this file does not have an extension. So the file is useless. It's not a Word file, it's not an Excel file, it's not a PowerPoint file, it's not a text file. It's just a file. So we can't really use this file. All right. So what do? We have to add an extension to this file, depending on what you want to use it for. So I can actually bring this script back. All right. Then put an extension to this file. If it's a Word document, the extension for a Word document is .docx. So I've added an extension to that file so that it is a meaningful file. So if I press enter now, it means it's saying true. It means I've created a Word file. So let's confirm if a Word file is in that folder. I can go back and open that folder, you see, there's a Word file there. So I can actually use this file. If I open it now, it will open as a Word file. So it can be used because it has an extension. Okay? It can be used as a Word file because it has an extension. See it, it has opened, but it's blank. There's nothing inside. Okay? So it's not only Word file you can actually create. You can create an Excel file if you want. If you bring it back, you can change the extension from doc to XLS, which is an Excel file, and press enter. The moment it says true, it means that file is there. So you can go back to that folder and check if there's an Excel file there. You will find an Excel file. You see, so that's actually how you create files, not necessarily using your mouse, going there, doing right click, you know. So that's how it's done. Now, if I want to know if that file is there, I can use this code, this function that says file exists. All right. So instead of coming to this folder to confirm if the file is there, I don't have to. All right. All I have to do is type the function file.exist. Then use this quotation mark and type the name of the file. So ACU underscore arrow files .docx, just to know if the file is there. So if the file is there, it will say true. If the file is not there, it will say false. You see? So the file is there, so it's telling me true. So I don't really have to open that folder to confirm whether the file is really there. Once I do this and I see true, I know that the file is there. All right? You can also find information about that file, meaning to know if there's really something in that file or if that file is empty, by using the function file info. So you can type .info. Then you can still type the name of the file, which is ACU underscore arrow files .docx. So it's going to give you file info. So see, the file info is giving you, say the size of the file is 0. There's nothing inside the file. It is empty. Like I showed you, the file is blank. Sorry, let me clean out this. The file is blank. All right, so you can see the size of the file is 0. So that is how you create files and play with files and all that. If you want to rename a file, like we have a file there now, which is the ACU arrow files doc. I don't want this name. I want to call it something else. So maybe instead of ACU, I want to call it Uniport. Ordinarily, what we would normally do is we'll come here. This is the file. I want to rename it. I right click on it and I go to rename. Then I can rename the file. That's it. But that's not how you do as a programmer. All right. You can actually do these things. You can actually do these things without having to go to that folder. So you use another function called what? File rename. So how does it work? You type the function name file rename. See it there is the third one. All right. Then you put the first file, the original file name, all right, which is ACU underscore arrow files. That's the first file name .docx. Then you put a comma after the quotation mark. Then now type the new file name you want it to change it to. So maybe this time I can say Uniport instead of ACU. Uniport underscore arrow files .docx. Then you press enter. True. Anytime you see through, it tells you that that has been done. Do we confirm that? Maybe let's confirm that manually. We can go to that folder and check. You see that the file has been changed. You see, there's no ACU arrow file word again. It's been changed to Uniport. But I don't have to open this folder to know. That's the point I'm making. If I want to know if that file exists, all I need to do is to type file.exist and type what was there before, which is the ACU underscore arrow files .docx. You see, it will tell me false because that file is not there anymore. But if I do file exist, and instead of ACU arrow files, I type uniport, which is the name of the new file, sorry, uniport, and press enter, it's going to say through. There's no ACU arrow files anymore, but there's a uniport arrow file. So this is how you work with creating files and folders in Arrow. You know, it's not like what we don't normally do, you know, when we are working with you know, our windows. All right, so I'm just trying to show you, you know, how programming, you know, does. So if I want to remove a file now as a programmer, normally what you do is you go to that folder and it will go off. But that's not how we delete folder, because you have to appreciate the fact that everything you do as a programmer, you use a script, use a command line to do them. You don't have time to be opening folder and going to, because you are very fast and you're coding and you're moving on. All right. You can't be using your mouse, go to folder, check, is it there? No, you use your code line to do most of the things you do. So if I don't need a file anymore and I want to remove it, I don't have to go. I can just type file dot remove. All right. Then I can put the name of the file that I want to remove. If it's that new file I created, which is the uniport underscore arrow files .docx. And if I press enter, it tells me through, meaning the file is not there anymore. And how do I know that? If I bring the one that says file exists, uniport, and press enter, it's going to say false. The file is not there anymore. If I'm not sure, you can go to the folder and check. You won't see the uniport file there anymore. It's gone because you've removed it. You see, so that's how it works, really. All right. So understanding your workspace, your files, and all that is really good as a programmer. You have to learn how to do these things. Okay. So another thing I can show you is sequence numbers. Then we can just progress straight to data analysis. But I needed you to have this foundation. All right. Now, sequencing of numbers, that one is pretty simple. So if you do 1:20, it simply means you're telling Arrow to list 1 to 20. That's what it means. There's no rocket science about it. So 1:20, if we press enter, it means list 1 to 20. All right. Now, another thing you would have noticed is Arrow has a way of using numbers when it's the first line. So when you see 1 means it's just one line answer. All right. So this is one line answer. This is 1, 2, 3, 4, 5. This is 13. Now this is 14. Okay. So it gives you number in brackets. If it's just one line, if it's 2 lines, if it's 3 lines, 4 lines, like that. All right. So this is the 14th one. That's why it's saying 14, 15, 16, 17, 18, 19, 20. So that's how it works. I want you to be able to appreciate that. Okay. So if you do pi, which is very popular, pi 1, this is what you're going to get. Okay, which is the 3.141. Okay, so if I do pi 10, it's going to give me the different versions of pi. So sequencing of numbers, if I do like, you know, you did 1:20, it gives you 1 to 20. What if you do 20:1? It will count backwards. So it will start from 20 back to 1. All right. So that sequencing of numbers is also something you should be familiar with. You should be aware of. So I just wanted you to know that. Now, let us progress to that sequencing of numbers. Now let's move to the data analysis itself. I needed to show you those building blocks so that when I begin to do the things I'm doing, you'll be able to appreciate where I'm coming from. So to analyze data in Arrow, I'm going to take you, step by step, okay? And like I said, this note is available for you. I'm going to share it so that you can use the note and also follow. Now, when you want to analyze data, the good thing you do is you can take a look at your data. I've created a data in Excel, which I'm also going to share with you. It's just a data that I created. I didn't get this data from anywhere. I created this data myself. All right. So this is what the data looks like. The data is in Excel, XLS. All right. So you can take a look at your data just to see if the data is okay and all that. It's a good practice to do so. Now, for data analysis, there are certain packages you will be installing, and I told you some of them to install, but not to worry. You can follow the videos later and practice yourself. But for now, I would be very happy if you can just pay attention to what I'm doing. Okay. So I had told you to install some packages. So we will be taking them one step at a time based on where we would want to use them. Now, there are two ways to install a package. Like I said, Arrow has over 10,000 packages, if not more. I can't say now, but I know it's more than 10,000 packages. All right. And there are people that are there designing packages and the rest of them for Arrow. All right. Because Arrow is open source, so people are happy to design package for it. So for you to do data analysis with Arrow, there are some packages you have to install, but you don't have to install all the packages. You can install the packages on a need to use basis, which I mentioned to you. So three of the packages we may have to install first is the Tidyverse, the Read Excel, and the ROCPP. I'll explain what these packages are, all right, in the notes that I shared with you. Tidyverse, it's used for data analysis. The Read Excel, it's a package that helps you to read Excel. So by default, Arrow will not read your Excel, especially if you had entered that data in Excel. If you had entered that data in a text, it will still not read it. For Arrow to be able to read that data, you have to install the package, which is this Read Excel. It's a package. You have to install it. Also, ROCPP is also a package that also helps your analysis process to be fast. So you also have to install it as well. So it's a package. If you want to know what they mean, we can just do question mark and type arrow CPP, and it will tell us what it is. So it's a C++ interface, like I mentioned to you. The ROCPP package provides C++ classes that greatly facilitates interfacing C or C++ code in Arrow packages. So if you don't install this, most times you may not get the speed that you want in the process in which this analysis is done, which is what I was trying to mention, to you. So that is what it does. If you want to know what read Excel does, you can do question mark and type read Excel. So that's it. It can tell you what it is. It's a package that helps you read Excel. So if you don't install this package, Arrow will not be able to read your Excel. If you did your data entry in Excel, it won't be able to read it. I'm sorry, I have to claim that. Okay. So it won't be able to read that, for you. All right. So that is it for the Excel. So let's see what Tidyverse does if you want to know about it as well. So let's do the question mark here and type Tidyverse, oh, sorry, Tidyverse, yeah, Tidyverse. Okay, it's a package. All right, it's not giving us anything about it. Says it's a package. Okay, we know it's a package. They don't have a documentation for it specified. Okay, it's a package that is in other libraries. So maybe there are other places where it is. All right, what if we do double question mark instead of one and type the tidyverse again and see tidyverse and see what it gives us. Okay, it's trying to give us something, but it's taking time. Okay, it's taking us to the manual itself. Okay, see the reason why it didn't give us. It's a big thing. It does so many things. All right. It has so many functions. So it Kukuma gave you the arrow manual for you to read all you need to know about the tidyverse. Okay. So if you try the one question mark, it doesn't work, meaning probably that package is so big that it can't just answer it in one sitting. So you can try double question mark, which is what I tried, and it gave me a whole big manual. So each of them have things to say about it. All right. So if you want to install these three packages first, you can do it in two ways. You can come here, Tools, click on Tools, go to Install Packages, and type your Tidyverse, see it there. Then you can choose your Tidyverse and install. All right, so I'm not going to click Install because I already have these packages installed. All right, I have Tidyverse installed. I also have Read Excel install is there too. You can see it. I also have the arrow CPP install. So I'm not installing any of these packages again, because if I click install, it's going to tell me I have them installed already. See, it's already telling me I have them installed. So there's no need reinstalling them. The only thing I can do is when you have installed a package, you have to activate that package. You know, that's how Arrow works. So in other words, the fact that you use install packages, read Excel. So this is the package. The fact that you have installed the read package does not mean you will be able to download, you will be able to import your Excel datasheet. It will not take it. You have to run library, then put the name of that package. That way, Arrow will load the package into the particular session that you want to do. All right. Without loading that package using library, Arrow does not know where to find the function and will give you an arrow. So the fact that you've installed the package doesn't mean you can just go straight and now import Excel. It will not work. You have to type library, see it there, then put the package, read Excel, see it there. Then you have to press enter. Now Arrow is clear that you now want to use that package as a function. Are you getting me? So sometimes you install and you now want to start using it, it will not work. You have to activate that package by using library, then in bracket you put the package. So I have activated the read Excel. So I want to now import my Excel file. So I go to File, I go to Import Datasets, File, Import Dataset. That dataset is an Excel. Then I have to go to From Excel. So that's how you can import your dataset from your system. So you go to File, Import Dataset, then you choose the format of the file. If it's an SPSS file, you choose it. But you won't be able to just import SPSS file without installing the package for SPSS? I think there should be a package for SPSS. Let's find out. Let's go to Tools, Install Package. Let's type SPSS. Let's see if there's anything I read SP. There's read starter. So there will definitely be read SPSS, but I'm not clear what the package name is called. So for you to even import starter, you have to install the package to be able to read it. So in our own case, we are putting in Excel. So we click on from Excel, then you come to browse here, search for where that Excel file is. So the Excel file for me is here in the materials. That's where, so this is the Excel file I am working with. So I'm going to open it. Then once it's showing here, then I will just say import. That's all I need to do, import. So that Excel file is here already. So I'm ready to start to analyze my data now. All right. So the file is there. So I can activate the two packages I've installed. Library, Tidyverse. Tidyverse is here. I can activate it. I've activated Tidyverse. Then, good, it's activated. Then, library, so that I can activate my ROCPP is here. So I'm activating it as well. Good. So I've activated my packages, so I'm good to go now. So the reason why I am using this console is because most of the things I'll be writing, they are just one line command. So I can use my console and press enter. But if I'm writing a script that is more than one line, I would do it here. So this is my data showing. I would now come to File, open a new arrow script and type them there. You will see I have an example of that as well. So this is my data. All right, it's showing here. So before you start data analysis, there are some things you need to do. There are some prep that you need to do. First, you need to know the class of your data. All right, you need to know the class of your data so that you can tell what the data looks like. So to know the class of your data, you can type the function class. Then you can type the name of the file. The name of the file, see it here, effect climate change. That's the name of the file. All right, so type effects. So once you type FE, the file will come out. See it there. You don't even have to type all. You can use your arrow and choose file. See it there. You choose it, press enter, it will select it. You press enter again. So it's telling you that your file is a data frame. What is a data frame? A data frame is a file that has a row and a column. So the class of the file is a data frame. See it here. So automatically you now know that this file you have uploaded has rows and columns. And that's a typical Excel sheet. Now, the reason why you are checking the class of your data, yes, I'm using a structured data now. The reason why I'm using a structured data is because most of us in this class, we are newbies. That's why I'm using a structured data. We're newbies, okay? I don't want to use something complex, all right? So I'm using a structured data, and this structured data is a data frame. It has rows, it has column, like you can see. In the rows here, you can see the rows here. 1, 2, 3, 4, 5, and you can go down. You can see the columns, region, age missing, age category, like that. All right, so it's a structured data so that it can help you really appreciate what I'm doing. Now, when you've checked the class of your data, the second thing you can do is to check the dimension of your data. How many rows your data have, how many columns your data have. So the function is called DIM, dimension. Then you can now choose your data. See it there. Press enter. So it's telling you this data you have has 800 rows and 31 columns. All right. So the dimension, which is DIM, gives you both. However, you can get them one by one if you want, but there's no need. But I just wanted to show you that if you want to know only the rows, you can use the function nrow only. Then type the data itself. All right. It can tell you the number of rows. If you want to know the number of columns, you can use n column. It's also a function. Then type the data itself. It will tell you, oh, it has 31 columns. All right. So if you don't want to use the DIN, which is dimension, to get both, you can do it individually if you want. Another thing you should do before you start analysis, you need to know the size of your data. All right. Because like for me, this data is small. So if I do object size, which is the function, and I put the data, and I put the data, this is it, object size. It tells me that the data is 207,176 bytes. It's a small data. That's almost like 207 megabytes. That's a small data, okay? You don't have a problem. My PhD, the quantitative component of my PhD, I used the data, a secondary data from DHS, Demographic Health Survey data, from 38 sub-Saharan African countries. Guess how many sizes that data? That data was almost 25 gigabytes with over 1 million respondents. So you can imagine, I used Arrow, I used SPSS at some point, I used Arrow at some point, especially the machine learning components of my PhD. I use Arrow all through for that because there's no way SPSS will be able to do that. Will be able to do machine learning algorithms. It doesn't have that capacity or that capability. All right. So imagine me doing object size for that data. It's going to show me. So the reason why you do object size, so that you know the size you're dealing with. If you think your computer does not have enough size to handle that type of data, then you have to change another system. Because oftentimes you may download this data, unstructured data. Sometimes you may download script data from Facebook, from WhatsApp. You don't just start analyzing that data. If not, you are going to hang your system. You need to know what is the size of this data that I'm going to be analyzing, and what size do I have in my system, especially in my storage drive. So object size helps you know the size of the data before you start analyzing that data. So it's very, very important to know. Sometimes too, you may want to know the name of the variables in that data. All right. If you check here now, you may be able to tell the names. So marital status, education, monthly income, weight. Why? Because this is a structured data that I created. Imagine a data you downloaded from WhatsApp. How do you know the names? Those are unstructured data. You will not know the names. All right? They are unstructured data. All right? There's no way that you will know the names. So like I said, the recording will be shared to you. Someone had an error. Sorry, let me just take a quick look at that quickly and see if it's something I can quickly help. Let me see. Someone had an error. Let me see. I'm trying to view. Oh, there. Where did I save it? I thought I saved it in download. Okay. Yeah, it should be in download. Let me check if it's there. Image. Okay. Let me see what the error is. Someone had an error. Required package version could not be found. ROCC 0 point is not available. Check that. Okay, so so this can happen when there's incompatibility between the package and your Arrow Studio. So I'm hoping you have the latest Arrow Studio. So maybe download the latest Arrow Studio and see. It's showing that that package may not run on the version of your Arrow Studio. Yeah, it said there's no package called read Excel. Well, I don't know that, but I showed you now. There's a package. If you go to tools and you type read, is there now? Read. See it here. Read Excel. So the one you did, yeah. So I don't know. See now, there's a package called read Excel. So I don't know. Why is that? All right. So it's not a problem. You can always reach out to me after this class and I can help you correct errors, okay, so that we don't spend our time correcting errors. Is that okay? All right, so if you will be wondering, oh, names. If you type names, which is the function, and you put the data, it will tell you the names of the variables in your data. So you see, it had already told me I had 31 columns. So you see, so it's correct. So these are all the variable names. And you'll be wondering, but I can see the variable names here now. Why do I need to new names? Yes, because I am using a structured data. So you can easily see the variable names. Like I said, imagine downloading a data from WhatsApp script or unstructured data. You would not clearly see the variable names like this. All right. Or imagining downloading a data that is in text script. They are not arranged like this. So most of these things I'm teaching you are not necessarily because of this data you have. It's mainly for a data that you may not see them clearly like this. And you need to know the names of the variables in the data so that you can know what variables to analyze. So it's very important. All right. So another thing you can do, I can look at this data now, but imagine you're not able to view this data like this. And you want to have a peep into that data. You can tell Arrow to list the first 6 rows of that data or the last 6 rows of that data so that you have a peep of what that data looks like. So the function is head. You can type head, all right, and type the data. That's it. So it will list the first, and if the first 6, and if you do tail, is the same thing, and you type the data, it can list the last 6. You see it. You remember this, our data has 800 rows, so it's there. So this is the last 6. Okay, so these are like things you do, more like surveying your data before you really start anything serious. So you can do head, you can do tail. All right, so now let's begin to progress to analysis proper. Now, there's a function that is called summary, especially for continuous variable. All right. So summary does not work for categorical variable. So when I say categorical variable, I mean variables that don't have numeric values. They don't have numbers. Like in this our data, we have categorical variables. Like region has rural and urban, is categorical. This our age category is already categorical. We have grouped it, so it's categorical. But our raw age is numeric, 36, 29, 30, like that. All right. Marital status is categorical. Education is categorical. Occupation is categorical. But monthly income is continuous. 5,000, 10,000, 15,000. So this function that is called summary, these are summary function. Once you type SUMM, AROY, not summarize, summary, it's a function. If you put all your data, which is the effect climate change, in this function summary, this is what it's going to give you. All right. It's only going to give you the summary for the continuous. Like you see for age, yes, it's telling us our minimum age, the first quantile, median, mean, third quantile, maximum. Yes, it's going to do that for the continuous. But when it comes to categorical, like sex, it's not giving you anything. So summary is not meant to be for categorical. It only works better for continuous. So if you're going to use the function summary, there's no need doing summary for all your data. Just do summary for the continuous data because that's where you need the summary. Sorry, let me clean this up. That's where you need the summary. So what do? You do summary, or instead of typing it again, you can bring it back using the arrow key pointing up. Is back. So you come in here and use the $sign. Once you put the $sign after the name of your data, it gives you an opportunity to select variables. So you have summary, your data, then the $sign. You see, so it's listing all the variable now. So I can choose continuous. Age is continuous. I can press enter to choose it. and another enter to run it. So you see, so it's giving me minimum, it's giving me median, it's giving me mean, third quantile, and maximum. So that's what you do, because summary is for continuous variable, not for all. If you run categorical, it's not going to give you anything. All right. So what do you use for categorical? It's table, not summary. For categorical, you use table. So once you put your table, which is this table, all right, you put your data, then you can put the $sign and select something that is categorical, like region, and you press enter. It's going to give you rural, you have 400, urban, you have 400. You can do another table. That's the table. You can fill in your data effects. Then use the $sign, maybe choose another, maybe age category. Now you can choose age category, enter. You see, less than 28, greater than 30, 316, 20 to 21, 154, 26 to 33. So you use table for categorical, but when it comes to continuous, that's where you use your summary. All right, that's where you use your summary. $sign, let me choose maybe income. Let me choose income, monthly income. So that's give the minimum monthly income is 0 naira, the maximum is 100, a million, right? These 6 zeros, a million naira. The mean is 30,797 naira. The median is 13,000. Okay, so that's it. So another thing you can do, which can give you more idea about the structure of your data, is string, which is the structure. ST arrow can give you the structure of your data. So if you choose the function ST arrow, you can add your data, effect of climate change. Then instead of running all your data, you can just choose maybe another continuous. Maybe let's choose BMI or weight this time. So for weight, so it's telling us that the weight is numerical, and is 1:800, meaning it's 800 rows. Then it is listing each of the weights that is there. All right, it gives you the observation and it lists each of it that is there. So the structure gives you a clue what type of values are inside that your data. That's what structure does. And you can do that for categorical as well. You put your data effect and use your $sign, maybe choose another categorical, maybe let's choose like marital status. So it's telling you that marital status is a character, not numeric. Numeric is number, but categorical arrow calls categorical character. Why it calls numbers numeric. So marital status is a character like categorical, and it has widowed, married, etc., etc. Now I'm sorry it's not listing more because of I had to compress my Arrow Studio so that I can have Arrow Studio side by side with the Word document, just to show you that I am following the Word document so that it will be easy for you to practice after this session, okay? To see that this is the document I'm following, you can use it to practice on your own. Okay, so we would progress with something else. All right, so let's progress with something else. All right, just a second. The Word document is scrolling. Okay, so now we're going into another form of data analysis itself. So like I said, I'm taking you step by step. We're progressing gradually. So for this type of analysis we want to do now, we will need another package called psych package. The full meaning for that is personality, psychometric, and psychological research package. So we're going to be installing this package. Just a minute, please.
Hello, everyone. Please, apologies. You will join us soon. Let's quickly address something. Please, just a minute.
Hello, everyone. Yeah, sorry about that. Okay, so like I said, we're going to be installing another package that will help us progress data analysis further. So to install the site, you come to tools. I think it's easier to actually do it this way. You can come to tools like I showed you before, install packages, and just type the package PSYCH. That's the package. You choose it and you click install and it's going to install. And when it's installing, you're going to see a red symbol cycle here to show that it's installing. Once that red symbol goes off, that's to tell you that the installation is completed. So that package helps us do other types of analysis. So now I have installed the package before. So we are going to activate it by using library. Then you type the package. Like I said, installing a package is not enough. You have to activate it by using library. So I have typed PSY and it's coming out now. I press enter, I select it, and I press enter. So the package is activated. So what do we do with it? The first thing we can do with this package is using a function called describe for descriptive statistics. All right. So when you run describe, it gives you mean, standard deviation, median, trimmed, and the rest of them. So I would not recommend you use describe for all your data. So if I do describe, all right, which is the function, and I type effect, I type effect and you choose your data, no problem, and you say enter. Fine, it's going to give you, a lot of but you see that it will only give you the analysis for continuous. But when it comes for categorical, it's not going to give you anything. It's going to be doing for region, see, it's giving you one, sex, one, marital status, one, education, one, because I mean, you can have mean, standard deviation, median for categorical variables. So what I would recommend is for you to maybe do your describe, then impute your data, then you can now use your dollar symbol and choose the continuous variable that you want to do describe for, like BMI, all right? And so that will give you your variance, your mean, your standard deviation, your median, your trim. Trim is actually a function that gives you a more robust statistics, in the sense that the mean value that is generated, the extreme values in the beginning and in the end will be excluded. That's what trim is all about. That's why you will see that your trim is closer to your mean. So it's more like a mean value that the extreme numbers have been removed. While your MAD, which is MAD, is actually the mean absolute deviation that tells you your MAD, which is the MAD, tells you the distance between one number and your mean. So which is about 6. It's almost like your standard deviation, almost similar to your standard deviation, but the standard deviation gives you a clue on how one number differs from the average of the difference between one number and another number in your data. So in this case now, it's about 5, all right? So meaning in our BMI, one BMI differs from another BMI by almost 5 values. But your mean absolute deviation tells you the difference between one value and the mean, of that BMI, which is about 6. So the MAD and your standard deviation oftentimes will be similar. Then it gives you range, it gives you skew, and it gives you your kurtosis. The skew is what you use when you want to check if your data is normally distributed or not, and is a very important process. So if your skew is 0, it tells you that your data is normally distributed. All right, meaning that the way you collected your data, you followed a robust sampling process in selecting that your data. Maybe you use simple random sampling, or you use stratified sampling, or use cluster sampling, or you use systematic, especially for hospital-based study. Like, you use the probability way in selecting that sample. You gave everyone equal chance of being selected. So that data oftentimes will be normally distributed when you run normality of that data, which I will show you later on how to do. So if you have a skew that is closer to 0 or 0, it means that data is normally distributed. But when you start having plus or minus, it means that data is negatively skewed or positively skewed, meaning favoring one form over the other. You know, a very good example I can give you, just imagine you are a medical doctor in a teaching hospital and you're a consultant and you want to do a research. And that research is about knowing the average income for health workers in the teaching hospital. All right. And you assume that health workers are only consultants like yourself, and you gave the data to only consultants. You find out that that data will be skewed, because when you do a mean of that data, it will look like the University of Port Harcourt Teaching Hospital is the highest paid teaching hospital in Nigeria, because you only collected data from high income earners. So that data is skewed, favoring high income earners. You didn't collect data from the warders. You didn't collect data from the lab technicians. You didn't collect data from other health cadres. You only collected data from consultants and professors. You see, so that's part of what could cause your data to be skewed. So in a case where you have a skewed data, using mean is not recommended. What is usually median. All right, if you have a data that is skewed and you've checked it using the Shapiro-Wilk normality and the data showed it significantly deviates from normality, then you're going to be using non-parametric method of data analysis like the median instead of the parametric, which is the mean. All right, so skewness is what you use to actually check for normality, and the kurtosis is also what is also used to check how slopey that normality is. You know, so when it's very slopey to the peak, is leptokurtic. When it's like broader, it's platykurtic. But at the end of the day, when you have 0 here, it means it's normally distributed. But when it's greater than 0 or less than 0, then you begin to have these different forms of kurtosis. All right, so that is it for the describe. Like I've shown you, it is a good measure when you now want to check all these descriptive statistics components. All right. So all these descriptive statistics components you need to check, you know, using the describe. Now this describe, like you see here, can give you all these descriptive statistics. But these descriptive statistics, you can still check them on your own, one after the other. In other words, if I want to check only mean for my age, I can just do mean, which is a function, then impute the data, all right? Then use the $ and maybe choose my age, which is this. It will just give me the mean age. If I want only the median, I can choose the function for the median, which is this one. Impute the data and choose age. It will give me median age. If I want standard deviation, I can do the same SD. So if I want to do them one by one, I can still do that. But if you need all of them together, then you use describe. Describe will give you all the descriptive statistics for the continuous variable like you have seen here. So what is another function we can do for our data analysis? There's another one they call the start describe, and we use pastec, which is still the same thing. So if you don't want to use this describe, you can use statistics describe, and you have to install the package called pastec, then do the library pastec, then you do start describe, then your data and age, and it's going to give you descriptive statistics as well. All right, so it's the same thing. Okay, so there's no need. So I have already, so if I do library and I run the pastec, which is that, then we can try it. So it's actually start.describe, which is that one. I load the data, then maybe we do that for age, which is continuous. So it gives me descriptive statistics, but this time it's usually adds exponential, which is easy to, you know, so it tells me that my minimum age is 1.6000 exponential plus 1. You know, what does that mean? It means plus 1 means if you add 1 0 here, it will now be 16. All right? Plus 1 plus 0 1 means add 1 0 to this 1.6. Instead of 1.6, it will now be 16.0. The same thing with the maximum. 4.1000 exponential plus 0 1 means you add 1 0. So that instead of 4.1, that will now be 41.0. So that's how the exponential works. Sometimes when you run analysis in Arrow, it can give you exponential. So you have to be able to know how to explain that. For example, now, if you have a coefficient of variance of 1.82 exponential minus 0 1, it means you have to minus, you have to minus a 0 1. So instead of 1.82, that will now be 0.18 because you're doing minus 0 1 now, not plus. So it will be 0.182. So that's what this exponential minus 0 1 mean. So that's how to interpret it, okay? So now, if you have a missing value, this is very, very important because there's a way Arrow behaves. Arrow is not very friendly with missing values, all right? For example, now, if I do mean age, so I have to load the data first, load the data, then I do my mean age. It's going to give me the mean age. But in my data, I have an age that I removed some values like age missing. I did this so I can use it to explain to you. This age and this age missing, they are the same data, but it's just that for this age missing, I removed some columns. Maybe I can show you better in the Excel sheet here. So if you look at the Excel sheet for age missing, you will see some yellows there. Yeah, so you see, I have a missing value here. All right. Sorry, let me make this obvious so that you can always see the headings. Freeze, stop. So if you scroll down, you will see that I have some missing. See, I have missing value here. I have missing value here. Arrow is not friendly with. So if you have a missing value in your age, so this one is okay, which is the age, but the age missing is not okay. Now, if I go back to my arrow, all right, now I do the mean for age, it will give me the mean 29.76. But if I do the mean now, I load my data again. I do the mean for age missing, the one I intentionally removed some values. You will see what it's going to give me. It's going to give you not applicable, meaning that Arrow is not friendly. The moment you have 1 or 2 missing values in that your data, it will not run. So you have to add the argument not applicable dot ROM, which is not applicable remove equal to true, which simply means that anytime you see missing values, which Arrow describes as not applicable, remove them. So you have to add that argument for you to be able to run mean or median or variance for variables that have missing values. All right. So you have to do mean, which is the function. Then you load the data. Then you have to use the $ to pick the age variable. Then after that, you have to do a comma, then then type the argument, which is NA dot, is already giving you option. You see, NA dot remove not applicable true, meaning I am endorsing you to remove anywhere you see not applicable. Remove it, don't add it in the analysis. So now it's going to work. It's going to give me a mean, which is 29.75. So I felt I should show you that anytime you have missing values, if you don't add the argument not NA.remove true, it will not run. That's why oftentimes if you're not sure whether there's a missing value, just add the argument so that if there's a missing value, it will just take care of it. But if you're sure there's no missing value, ROM, there's no need. All right. So another thing we'll do now, we'll just do some graphical. Tomorrow you actually be doing visualization, heavy visualization, but these are just minor graphic display for your descriptive and inferential statistics. All right. So to do this, you have to install the package, which is gg pop arrow. Then you run it. I've showed you how to install packages. So, but this time I have to activate that package because I already have it installed. So I do library, then gg pu, as it to show you the package is already installed. So I've activated it. So I want to run a box plot for age. So this is the code line. All right. So the gg box plot, which is the function, you load your data, comma, then you tell it you want age in y-axis, then you want it to be a width of 0.5. So this is what I typed here. So instead of retyping it because of time, I can just copy this. I've explained what it is. You can put it here, then run it, and it's going to give you this. So this width is actually 0.5. If you want this width bigger, you can change the diameter for it. So if I recall this back, instead of 0.5, I can do 0.9. Instead of 0.5, I can do 0.9. If you run it, you see that the width will be bigger. If you don't want 0.9, if you want it to be smaller, you can change it to 0.3. If you press enter, you see the width will be smaller. All right, so that is for box plot. And you do box plot for continuous variable. You can't do box plot for categorical variable, because this line here that is shown in the box plot, that is the mean line. That is the mean line that shows here. Why this up part and this down part, they are more like the confidence intervals. So that's the script for box plot. Another thing you can run is histogram. So for histogram, it's still the same package, but for histogram, you use gg histogram. All right, you follow the same pattern. You load your data, you put comma, you tell it where you want the age. You want the age in the x-axis. You see the age is already in the x-axis. Then you want it to put 9 bins. 9 bins is what you want. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bins. Then you want it to add a mean line. So this is the mean line. So that's what this script means. So I've explained it. So I can just copy this, put it here in the console and run it and see it. So it has given me what I asked it for. If you don't want 9 bin, it's not rocket science. It's not cast in stone. You can change this 9 to maybe 6. You want only 6 bin. If you press enter, it will reduce it to 6 bin. So it will reduce it to 6 bin. All right. So that's how it works for histogram. So histogram is also for continuous variables as well. Histogram doesn't work for categorical. What you do for categorical is bar chart. Histogram. All right. So another thing you can do, I don't know if you've heard of empirical cumulative distribution function. It's you use it to check if your data or the data you have is as good as the sample population. So if you run it and you have a graph like this, what it means is as your population age is increasing, because anytime you have a graph that you have a line moving this way, it means as the vertical is increasing, horizontal is also increasing. That's what this line means. So when you run your ECDF and you have this, it tells you that as your population age is increasing, that's how your sample age is increasing, meaning that the sample you took is very close to the population. So that's what you use the empirical cumulative distribution function to do. All right. So use this GGECDF, then you load your data, put a comma, then tell it where you want your age, which is in the X axis. That's your sample age is in the X axis. Then it will bring out the population age and tell you whether they are similar. So this is showing you that as one is increasing, the other one is also increasing. I can copy this and paste it in my console and run it, and you will see it here. So that is what it means. All right. So another thing you can do is your ggplot, which you can use to check if your data is normally distributed. All right. So let me put, so is the ggplot, you load your data, comma, then you tell it where you want your age, which is in the x-axis. Okay. So if I load this, if I copy this and I paste it in my console, don't worry, I'm going to send this document to you. You can also use it to practice as well. If I load it, so this is the age. Now, this photo that is here, if you want it to be bold, all right, you can click on zoom. If you want to export it somewhere else, you can click on export. Say I want to save image, then you can choose where you want to save this image in your directory. Then you can save, all right? But if you want to view it bigger, you can click zoom and it's going to show you bigger. So what this is telling you is that most of your data are falling on this line. As you can see, most of the data are falling on this line. It's just a few that are outliers, but majority of them are falling on this line. So that tells you your data is normally distributed because you have most of your data falling on this diagonal line. So anytime you do a chart to test normality and you find most of the data falling on this line, then it tells you that that data is normally distributed. All right. So if we don't want to do age, let's try for BMI. I'm calling it back. So instead of age, I'll type BMI. Let's see what BMI looks like. BMI. So look at your BMI. You see, your BMI is not normally distributed. You see, majority of the data is outside the diagonal line. So you see the difference now. For your age, you see most of them are on this line to tell you that your age is normally distributed. But for this, your age is sort of normally distributed. It may not be, but it's closer to being normal than BMI. See, BMI is far apart. All right. I think it's the Shapiro week that will truly tell us whether it is normally distributed. All right. Okay, I think that is it for the, so let's look at something else. Yeah, so you can do compare, like checking your summary, your, check your mean age or mean BMI for each category of something. So that one, you use a package called dplyr. Dplyr helps you to do statistics by group. So you have to install dplyr because it has this function that is called a chain operation function. So without installing the package dplyr, you won't be able to do summary statistics by grouping. All right. So this package dplyr is available. All right. If you want to install it, you can go to tools, install packages, and you type your dplyr and it's going to come out. All right. So I have installed it before, so I'm only going to activate it by typing library and dplyr, dpl, see it there. So I press enter, so I've activated it. All right. So I want to do group by, which is the function group by. So if I do group by, then I'll put the bracket open, then load my data, which is effect for climate change. All right. Then add the categorical variable, which is education. Then use the chain operation from my dplyr. This is the chain operation from my dplyr, and tell it that for each of the category of the education, I want the mean and I want the standard deviation. That's what this code line mean. So group mean age, standard deviation age by each category of education, using the dplyr chain operation to help me do that. So I can copy this, I've already done, copy it, put it here in my arrow and run it. See it. So it has given me the mean. It's giving me the count. Sorry, I said the count. Sorry, I wrote count, then mean and standard deviation. So it has given me the count. For none, I have 68 in terms of the number of those that have no education, 68. Those that have primary, 132. Those that have secondary, 208. And those that have tertiary, 392. Then for the age, for those that have no education, 28.7. The mean age for primary is 31.8. Mean age for secondary, 28.7. Mean age for tertiary, 29.8. So if you're looking at these mean ages, you can see that primary has the highest mean age. After primary is followed by tertiary. After tertiary, then non and secondary have equal mean ages. So that is what you use the dplyr for. You can represent this data in a box plot, still using your ggpop that I showed you before. You can represent this data in box plot using the ggboxplot. You load your data. You said you want education in the x-axis, then you want your y, which is the continuous variable, in the y-axis, then you want color for each of the category of the education. So that's what this my line code is saying. So I can just copy the line code, paste it here, then run it, and you see it's going to give me a box plot. I can zoom it so that I see what is happening. So because of this color, it's giving me different color for primary, tertiary, secondary, and none. You will observe that the tallest is the primary. Why? If you look at the mean, see it here, primary has the highest mean age, 31.8. That's why this one, the mean age here is 31. See it here, is higher than this and this. So this is higher, 31 in terms. So this line in your box plot is the mean. All right, this line in your box plot is the mean here. All right, so you see it's giving you the mean. All right. Okay, so what else is there? There's also a chart they call strip chart that can give you the number. Strip chart can help you know which educational level is more concentrated in terms of number. All right, so you can use strip chart. The function is gg strip chart. It's the same code line, but it's just that instead of using ggboxplot, you're using gg strip chart. So we can actually copy this code line, put it here and run it. So this is what it is giving us. So you can see that looking at this alone, you can tell the level that has more participants is tertiary, because you see tertiary is more concentrated in terms of dots. All right, so look at it here. See, tertiary is 392, followed by secondary, which is 208. So you can see that after tertiary, the one that seemed to be more concentrated is secondary, followed by primary. All right, none is scanty. Why? Because if you check none, it's only 68 here, so it's actually scanty. So that's what you can use the strip chart for. All right, so let us make progress. So let's move further because of our time. So now we will do correlation. You know what a correlation is? Correlation is used to check if there are associations between two continuous variables. In other words, if one continuous variable is increasing, is the other continuous variable increasing or reducing? All right. So one thing with correlation is it works for continuous data that are normally distributed. If your continuous data is not normally distributed, it is rank. You're not using, we don't use correlation, Pearson's correlation for rank data. We use Kendall, Tau, Spearman rule for rank data, or for data that have ordinal rank data. So you use Spearman or you use the Kendall. But if the data is normally distributed like continuous, you use Pearson's correlation. All right. So, and the way the Pearson's correlation works, the value is between 0 and 1, meaning 0 means 0%, 1 means 100%. So it runs between 0.1 to 0.9 to 1. So if you have a Pearson's correlation of 0.5 below, it is weak. If you have a Pearson's correlation of between 0.5 to at least 0.7 is moderate, but 0.8 to 1 is strong. All right. If it's the positive, it means if the independent continuous variable is increasing, the dependent continuous variable is also increasing. But if it is minus, it means as the independent continuous variable is increasing, the dependent continuous variable is decreasing. So positive means increase, increase. Negative means increase, decrease. So that's how the Pearsons work. So the function for correlation is CO arrow. But if you want to get the test value, then you use the CO arrow dot test. All right. So as you can see, 0 to 1.9, very weak. 0.2 to 0.39 is weak. 0.4 to 0.59 moderate. Then 0.60 to 0.79 is strong. 0.80 to 1 is very strong. All right. So how do you test normality of your data? Like I said, I was going to show you. You use the function Shapiro weak. All right. So you can type the function here, which is the Shapiro weak normality. That's it. Then you load your data, effects, load your data, then choose the continuous, because normality of data is only tested for continuous variable. You only test it for continuous variable, all right? Because it tells you if that data is normally distributed. So we can do that for BMI, we can check, or we can do for height. So I'm choosing height. So if I run this now, you see the p-value is less than 2.2 exponential minus 16. What does exponential minus 16 means? It means is 16 zeros before 2.2, because you see is minus 16 means 0.000 up to 16 times, then 2.2. So 0.000000 up to 16 times before 2.2 is less than 0.05, which is the cutoff. So that's significant. So this is the value, which is 0.91, but is the significance that tells you whether it's normally distributed or not. So if your p-value is statistically significant, it means that variable significantly deviates from normality. If your p-value is 1 now, is less than 0.05, you are testing significantly deviates from normality. All right. So this data now is skewed. That's our height is skewed. So that's how you check for normality of that data. All right. So if that data is skewed, what you will most likely be doing is non-parametric, which is median and interquartile range. But if the data is normally distributed, then you'll be doing mean and standard deviation. So mean and standard deviation is for normally distributed data. It's called parametric method. But median and interquartile range is for skewed data, those that are not normally distributed, and it's called non-parametric. So that's how it works. So that's how you check for normality of your data. Okay. So to run a correlation, so is COR. That is the function for running a correlation. But first of all, you can assign, you see that assigning key now is here. You can assign the two continuous variable you want to use for correlation into a new variable, maybe call it core data. Then load that data into the function of correlation so that it will now give you the correlation. All right. So you've seen the assigning key now has become very beneficial because I don't want to be typing effects, concatenates, monthly income, and BMI, because you are joining monthly income and BMI to be able to get a correlation. So you're using concatenate. You see that thing I was telling you before? Then you now assign it to core data so that anytime you type the core data, it means effect climate change, joining monthly income and BMI. Then you can now use the function correlation to analyze the data. All right. So we can do that. We can type that, or we can just copy this. All right. Because of our time, because I've already written the code, so no need retyping it again because of time. You can copy that and paste it here and run it. Then you can now use the correlation function, which is COR. Then put in that data you had created, which is COR underscore data, see it there, and run it, then it will give you the correlation. Now, if you look at this correlation, monthly income against BMI, this is minus 0.013. So what does this minus mean? This is 0.01 is weak already. 0.01 is what? Weak already. For it to be strong, it has to be like 0.7 up. But 0.01 is already weak correlation, and this is negative. So what does that tell you? It tells you that as the monthly income is increasing, the BMI is reducing, which could also mean that as people have more money, they eat better food. Meaning if you have less money, you may spend more time eating junks, and that may make you fat. But if you have more income, you eat more balanced diet, more vegetables and the rest, so that will reduce your BMI. So this could mean as the monthly income is increasing, the BMI is reducing because they have more money to eat healthy. So they are not fat and obese, like eating more of junks. All right. So you can actually run a correlation test so that you don't only have the correlation, because here you only have the correlation, whether it's increasing or decreasing, but you don't have the test, meaning you can't tell whether that correlation is statistically significant or not. So that's where, in this case, you can now use the core test. So we want to run a correlation between age and BMI to see whether, if age is increasing, what is happening to the BMI. Now, you can have a null hypothesis on this association. What will the null hypothesis be? There is no difference, or there's no significant association between age and BMI. Since age is a continuous variable and BMI is a continuous variable, the only test we can use is a Pearson's correlational coefficient, because it is used to check if an association exists between two continuous variables. So for those that are posting, in terms of troubleshooting, Victor will try to help you. But if Victor is not able to help you, please, you can reach out to me later on, and I'm happy to guide you through a call or through messages. Is that okay? But like I said, it will be difficult to troubleshoot. That's why when I sent the email on Saturday, I encourage those of you that are having challenges to reach out to me. So it will be very tough to do troubleshooting here, but I'm happy to support you after the session so that you'll be more loaded to, to also partake in the visualization session for tomorrow. Okay, so pardon me if I'm not able to address your troubleshooting queries. So like I said, age is continuous, BMI is continuous. That's why we are using Pearson's correlational coefficient, because you use it to check if association exists between two continuous variables. All right. So we use the core.test because we don't only want to see the correlation, we also want to see the significant value. Because if you run a correlation like you have run here now, for this one you have run, and it's telling you that as the monthly income is increasing, the BMI is reducing. What does that mean? There's no significance, so you can't tell whether this association is statistically significant or not. So you won't be able to accept or reject your null hypothesis. So your null hypothesis is saying there's no difference or significant association between age and BMI. So let us find out. All right, so that's our null hypothesis. So we're going to be running this. So it's the same process, all right, but you are using the core test because that will give you a significant difference. All right, so you can run this alone or you can assign it to Pearson's, depends on what you want. So in other words, I can type the core. So because of time, let me not be retyping this. I've already written it already. So let me just copy this function here, all right, and paste it here and run it. You see, so the correlation is going to run, all right, or you can assign it to Pearson's if you want. Pearsons. You can assign it to Pearson's so that when you type Pearson's, it will still come out. It's the same thing depending on what you want. All right, so in this case now we can see the correlation here, minus 0.09. This is the 95% confidence interval for the correlation. All right, this is the correlation itself, 0.0 minus 0.09. First, this is weak. This is what? Weak. All right, what it means is as age is increasing, the BMI is what? Reducing because of the negative sign. And this usually happens to people that are malnourished. Their age is not equivalent to their BMI. They might be growing in age, but they are malnourished. So you find out that as the age is increasing, the BMI is reducing due to malnourished. But what is the evidence here? Is it statistically significant? Let's check the p-value. This is the p-value, 0.0082, which is less than 0.05. So our p is statistically significant. So because our p is statistically significant, what do we do to the null hypothesis? We reject our null hypothesis that says there's no difference or significant difference. We accept our alternate hypothesis that says there's a statistically significant difference between age and BMI. All right, sorry, I think I meant age and BMI here. Sorry about that, not monthly income. Age and BMI. All right, so that is it for the correlation. There's no rocket science about that. All right, you can do the same for monthly income and BMI. It's the same process. All right, but in this case for monthly income and BMI, the P was not significant. So meaning that we'll accept our null hypothesis that says there's no difference between monthly income and BMI. So meaning monthly income does not influence BMI in terms of the correlation here. Okay. So if you're running a rank, like there's one data that is ranked, which is the degree of disease. Degree of disease is ranked. All right, so because degree of disease is ranked, we are not using Pearson's. We are going to be using the Kendall rank correlation coefficient. All right, so that's what we are going to be using. If you look at this one, you will see that the method at the end is Pearson's because these two data, they are continuous, they are not ranked. But if you look at this one, you will see that the method is Kendall. The reason why we are doing Kendall is because degree of disease is a ranked variable. It's a continuous, but it is ranked, more like ordinal. You know, more like ordinal continuous. All right. So so you can run this, you know, and it's going to run. All right, it's going to run. So this is it. It is minus 0.003. It is weak. It is weak, negative, but the P is not significant. So There's no association, so no need bothering yourself in explaining it. Okay. So you can run a scattered plot. The command line is very long, but I can explain it. So it is ggScatter, that's the function. Still under the package you install ggpop. So you run the library, then the function is ggScatter. You load your data. You say you want age in the x-axis, BMI in the y-axis. Then you want it to add regression line. You want it to add regression line. Then you want it to add the confidence interval. You want it to add the correlation coefficients, right, which are these 0.09. You are doing Pearson's, all right? So you age to have a label, yes. You want the BMI to have this label. So that's what all these functions simply means, okay? So no need retyping it. I've done that already. I'm just trying to explain what I wrote. So you can copy that and paste it here and run it, and it's going to give you the correlation. Zoom it. So this is it. So all these things I've written, they are here. I said I want label. The method I want is Pearson's. Why Pearson's? Because we are dealing with age and BMI that are continuous. I want a label. Where you have age, you should have a label years. Where you have BMI, you should have label kgm. So it has given you the label here. It has given you the label here. It has given you the coefficient. It has given you the p-value. It has also given you the regression line, which I requested for. Add regression line, all right? So you can see this data now. It is weak. If it is strong, the arrow will go this way. If it's strong, the arrow will go this way. It is negative, it is going like this. So if the line goes this way, it is negative, but it would have been strong, but it is going like this, but it is weak. That's why it is this way. So it is negative, but weak. If it's negative strong, it would have gone this way. If it's positive, it would have gone this way. You remember I showed you the diagram for the correlations, how weak goes, how strong goes. Okay, so I think that is it for this. Now for frequency table, I told you if you want to do frequency table, you do table or F table, all right? So you can do table, which is this. You can load your data, then you can do the table for the categorical, like marital status, all right? But you can see that it's only giving you counts. It's not giving you percentages. So if you want to run percentages, you use prop table. Prop table will give you percentages. All right. So if you run the same, but use prop table, let's say if you assign this now, you have done this effect. All right. You assign this table to maybe proportion or anything, maybe assign it to proportion. Assign that to proportion. Then you do prop table, then impute that data, which is the proportion. The proportion, yeah, that's the data you had created. You see that it will give you percentages. So if you times this by 100, it's going to be giving you 1%, but this one is going to be giving 5.2%, 74%, 2.5%, and 1.7%. All right. But you don't have to go through this process now. This process is cumbersome. I've written a code line that will give you a table. All right. So this is the code line, which is it will give you count and percentage table side by side. So I've written it. All right. So this is it. You can copy all this. So I forgot to mention this to you. Anytime you see a hashtag, it means it is for you to read. If you don't see a hashtag there, it is for the software to run it. And the software understands that. So even if I copy all this, So this is more than one line. So I can't paste it in the console. It will not work. So because it is more than one line, I have to paste it in the script. So I have to copy all these I have written. I'll explain it to you. So let me copy it. So I'll copy all this. Sorry, just a second. It's taking time. Okay. So I'll copy all this, copy, and I'll create a new script. So you come to File, New File, then Arrow Script, paste it there. Then highlight all of them. So you see, once you have this hashtag, Arrow will not run it. Anytime you see a hashtag, it means that instruction is for you. All right, Arrow will not run it. Arrow will only run the ones that don't have a hashtag. So it doesn't really matter. All right, so I can highlight all this and run it. So this is the run. So you see the table. So it will create the variable name, the frequency, and the percentages. So I've created the code line. So first of all, I did the frequency table for education, which is this one. So if I run only this one, only this is what is going to give me. You see that? Only the frequency, only the counts, which is what you're used to. But now I want a data frame. What is a data frame? I want rows and column, and I want it to name the variable names. That means the non-primary, secondary, tertiary, to name them. I need a frequency, I need a percent to round it up, all right, to percent. So that is it. So that is the instruction that I gave here, which is what it has done. If I want a total, I have a different instruction. If I want a total, I have a different instruction here, which at the end of the day, it will end up giving me a total. All right. So this is the total, existing total code. So these codes, they take time to write. So I've written them. So the only thing you can do if you want to use this code line is to replace the variable name. For example, now, look at this code line now. The variable name that is here is education. All right. If I don't want education, I can replace this education with another variable, maybe region. So I can replace this education with region. Okay. If I don't want education, I can replace it with region. And the code line will still run, just to be sure you don't have any education anywhere, and highlight it and run it, and it will still run for region. Are you seeing it? So these codes have taken time to do. The only thing you can do is just change the variable name and it will run for you. So in this case now, just copy all this code line for the total, copy it. You can delete this one, paste it in a new script, highlight it and run it. And it will run with total. It will run with total. So if you don't want to use education, which is this, replace the education with something else. Maybe let's see another this thing, occupation. You can replace the education with occupation, and ensure that there's no education anywhere again. So just confirm there's no education anywhere in the code line. Once you confirm there's no education, you can highlight it and run it, and it will do the same for occupation. The variable names, the frequency, and the percentages. So all these code lines I've given, all you need to do, just replace them with the value that you want to do. If you have your own data, first of all, import your data and replace, and once you import your data and you activate the package using library, you can put this code line and just change it with your own variable name. All right, so let's do cross tabulation. We are almost wrapping up. Cross tabulation, you know now, like you want to do cross tabulation with Chi-square and the rest of them, you have to install three packages. You have to install the janitor, you have to install the dplyr. We have done that before, so no need. Then you have to install the knitter. This knitter is what you use when you want You know, like you can see now, this thing has variable name, frequency, and percentages, but it doesn't have lines. It's not drawing lines. So if you want lines on the table, this is the package that you use to draw lines on the table. All right. So cross tabulation for categorical variables, if you want to check if there's a difference in independent categorical variable, you want to see if there's a difference in percentages, you use the chi-square. Chi-square helps you check for differences in percentages. Okay. If there are individual cells in that association that is less than 5, you use the Fisher's exact P. If you're checking for differences in percentages, but that percentages is a pre and a post, you use the McNeema, not chi-square. You only use chi-square for differences in independent percentages. Okay? Independent percentages. But if it's a pre and a post percentages, you use the McNeema. All right? So for the first hypothesis, let's say we want to check differences in gender and disease. The disease I have here is whether they have disease or they don't have disease. That is a yes and a no. So we can find out the values we have in disease. So we can do table. Oh, sorry. It's not this table. Table is this table. Sorry. Table, this one. Yeah. I can load the data. Then I can look for disease, so that I know what values are there. So I'm correct. Yes and no is what is there. Okay. So I'm correct. So we want to see how sex is associated with disease. Yes or no. So I'm going to be running the library for the 3. So I'm going to run that has been installed. I'm going to run library for genital. Then I'm going to run library for neither. I've already done for dplyr. So I'm going to run library for KNI so that I can have lines in my tables. If you don't activate that, you will not have lines in your table. It should just be like this. All right. So all I need to do is copy this. So let me explain the code. So it's the same table, more like a tabular form. Then tably means draw a table. I've loaded my data. Then that table will be for sex and disease. Then join it, which is what the dplyr does. Join it into total, frequency, percentages. All right. So you're doing sex for disease, each value of sex against disease, but join it to have counts, which is frequency, percentages. So that's what this means. And also do total. All right. So this cable, it helps you draw these lines. So all you need to do is copy this function. All right. Paste it in your arrow script. You can delete this, paste it there, highlight it and run it. And it's going to give you the same table. See, this same table that I have here. Now you will notice that this table is already telling you disease no and disease yes. So for female, you have 30% do not have disease, 70% have disease, total 500, 600. For male, 40.8% do not have disease, 59.2 have disease. So if you look at the male and female, you can see that females have more disease than male. But there's no evidence to say that disease occurrence is significantly higher in female. So that's why you need to do the chi-square test for this tab. So what you have done now, you have assigned this your code to tab. you have assigned it to tab. So if you say tab, if you say TAP, it's going to still run that table for you, because that is what tab is. So you can add this data you have run into the chi-square, okay, by doing chi-square, because we want to know if it's statistically significant or not. We've run the table, is showing that the percentage for disease is higher in female than male. What is the chi-square saying? What is the evidence, which is the p-value? So we choose our chi-square test. Then you load your data. All right. You choose the first, which is the sex. You do a comma. You load your data again. Then you can now choose your disease, which is this, to run your chi-square. So you run your chi-square. So your chi-square test is saying it is chi-square is 8.4022. The p is 0.003, which is less than 0.05. So it means your p is statistically significant. So your null hypothesis says there is no difference between sex and disease occurrence. But based on this p-value that is significant, we'll reject our null hypothesis and accept our alternate hypothesis that say there's a significant difference between sex and disease. Why? Because females have a higher occurrence of disease, 70 against 59.2, and that difference is statistically significant based on the evidence from our p-value, which is less than 0.05. Our p-value is 0.003. So we can beat our chest and say that females have more disease than males based on this data. All right. So if we look at this data now, we can see that all the counts we have here are greater than 5. 168, 98, 392, 142. They are all greater than 5. So chi-square is applicable for this. All right. Who's now? Stop writing on the screen. Okay. So all these are greater than 5. So chi-square is appropriate. But assuming that we have values that are less than 5 here, maybe instead of 168, we have 1. Instead of 98, we have 4. Once you have values that are less than 5 in this table, you can't use chi-square anymore. What you're going to be using will be Fisher's exact. So let's assume that we have values that are less than 5. All right, we'll use Fisher's exact. All right, so instead of chi-square, you type Fisher's. So it's there. So Fisher's test. So you do the same thing. You load your data. All right, $, choose your gender, you do comma, you load your data again, $, then you choose your outcome, which is the disease, and you run. So it's giving you the Fisher's exact P. So Fisher's exact is a type of a p-value. It's not a chi-square. It's a type of a p-value. That's why sometimes when I see people make a table for association, they will not write chi-square value, not write Fisher's exact value. It's not correct. Fisher's exact doesn't have a chi-square value. It's a special type of p-value that adjusts for small numbers. So if you're using Fisher's test, you will only have a p-value. It doesn't have chi-square and Fisher's exact p. All right. So you only have chi-square and p-value, or you have a Fisher's exact p, which is applicable when you have numbers of frequency counts that are less than 5 in your table. In this case, it doesn't apply, but I'm just trying to show you. What if you want to do multiple data? All right, instead of doing only sex and disease, you want to check other independent variables apart from sex. So I have already written the code here, all right, because of time. So all you need to do, everything here, the only place you will be changing is at this point here. This is the only place where you will be changing with your own variable name. BMI category, flawed. So I'm doing an association between sex, BMI category, flawed, and contamination. So this is the only place where you will be adding the variable name, like I've shown here, variable name, variables to analyze. Every other thing, there are code lines you can use and just add your own variable line. All right. I've already written that you should run a test as well. All right. So all you do, so what I did here, I only asked it for p-value based on this code line. So if you copy this code line, it will end with results. That's it. And you paste it here, highlight it, and you run it. It will run. It will run the tables, but it will only give you p-values. It will not give you chi-square, because in the code line, I only asked it to generate p-value, but you need p-value and chi-square. All right. So if I make this bold now, you will see that it's only giving you p-values. Okay. But the test of significance is not p-value. The test of significance is chi-square. P-value is the clue, the evidence that the chi-square is statistically significant. So there's no way you run only p-value. So this code is missing chi-square. So I did another code down here that has the chi-square and the p-value. All right. So we are going to copy this one and run it. We're going to copy this one and run it. I'm sorry, because of time, I had to do all the code so that we don't have to be doing it here. So I'll remove this, paste it here, and run it and bold it. So you will see that, okay, the result, yeah. So let me run this. Okay. Then the result, which is this. So this is it. Okay. Results. Oh, there. So sorry, my word is really. So if you run the code, you are going to have this. You are going to have the chi-square, which is 8.4. You're going to have the p-value. It will give you chi-square and p-value for each of the table. Okay, for each of the table. So let's move, because of parametric, let's move to parametric. I think we will be wrapping up here. So parametric, like I mentioned, is when your data is normally distributed and you are using association of means. Non-parametric is median. Okay, so when you want to do like one sample t-test, one sample t-test can only apply if you have a mean already. For example, now we are talking about heat waves, and news have shown that the heat waves value for Nigeria is 35. You have now collected the same data probably in another city like Port Harcourt or Lagos, and you want to run a one sample t-test to see whether the heat waves in Port Harcourt is significantly higher or lower than the heat waves in Nigeria as a country. So this is the code you use, is t-test. All right. So you load your data, you select your continuous variable, you add the value you are comparing with. Then you tell us whether it's two-sided or one. Of course, it will be two-sided because you're checking both direction. So if I copy this and just paste it here and run it, you see the mean heat waves for Port Harcourt is 47.93, which is higher than that of Lagos, that of Nigeria, which is 35. So is that increase statistically significant? Yes. Our p-value is 2.2 exponential minus 16, which is 0.0000 up to 16, then 2.2. So the interpretation of this is that the heat waves for Lagos is statistically significantly higher than the national heat waves value of 35. So that's what one sample t-test is usually used for. All right. You want to compare whether the mean for the location you collected is higher or lower than the national average. That's what you use one sample t-test for. But for independent two-group t-test, for independent sample t-test, is when you want to check the mean difference between two values in a categorical variable. So one categorical variable we have in this data is disease, is a yes and a no. So we want to check the heat waves, the mean heat waves amongst those that have disease and those that don't have disease. So we do the t-test. All right. The t-test is what we still use. The t-test, so it's here. So we do the t-test, we load our data. Then we select our continuous variable, which is the heat waves. All right. Then we use this symbol to link it with the disease. All right. Then we choose our data again. Then we use the dollar symbol to now choose our categorical variable. So we are looking at the mean heat waves between the yes and the no. So from this data now, you can see what is happening. So the mean heat waves for no is 32.79, while the mean heat waves for yes is 55.46. So what is that telling you? The mean heat waves for those that have disease is higher than those that don't have disease, 55 against 32. But is this difference statistically significant? We check our p-value. Our p-value is less than 0. It's more like having 0.0000. So it's less than 0.05. So we can say, so if our null hypothesis was there's no association between heat wave and disease caused by climate change, because our p-value is significant, we will reject our null hypothesis that says there's no significant association because our p-value is statistically significant. I think this is where we'll wrap up. I think that's more like it. So we have exhausted our time. So I'm going to share this note with you so that you can also practice. So thank you very much for your time. Yeah. So thank you very much, everyone. I'm happy you showed up. So so let's take a few question and answer before we wrap up for the day. So the recording will be shared and the lecture material will be shared. So please, if you have put a question on the chat box, are you happy to share it? Victor, could you please repost that survey form again? So let me give everyone an opportunity. Yeah. So let me give everyone to unmute. You can unmute yourself and ask your question. Victor is going to share the survey again. So please fill that survey because that is the survey we are using to check attendance. And that is the survey we are using to make your certificate available because your name will be there. All right. Because Zoom is not able to keep attendance for us. All right. So questions and answers, please. Yeah, thank you.
Good evening, sir. Please,
Good evening.
question is, my name is Roslyn. My question is, I've gone through all the lectures you've given us like now. At the end of the day, to summarize this and put it in a note form, you are going to go back to our script and pick it one after the other to form a note, like to form a presentation and I mean all these analysis I'm talking about. Is that it?
Actually, what I'm saying is, you know, the arrow. So what I'm basically saying is this arrow now, this stuff here, you have 4 parts. You can write your line here and run it. So what I'm saying is that this line here now, I can write it afresh. But because of time, if I keep writing all the lines afresh, we'll be here for 5 hours. So I've taken the time to write the code line in a note that I'm going to share with you. So what I'm saying is that you can practice on your own. But instead of typing all these things, because sometimes when you type this, you may make mistake. All you do is that you can copy this, copy it, put it in your arrow script and run it. Because if you check this code line that I've written, the only thing that you will need to change here is the variable name, which you can replace with your own variable name, or if you're using the same data that I've given to you. So that is what I meant. So you can copy the codes from the Word document, paste it and run it, and they will run. Instead of having to type them afresh. Sometimes when you type, you can make mistake until when your hand is now stronger to write your own codes. I don't know if this is clear.
Thank you so
Then
much.
how can
Thank
we
Alright.
you.
move
Yeah,
between
thank you.
different model?
Hello, you said
Then
what?
how can we move from different model of analysis?
What do you mean by different models?
Maybe I want to run multiple regression, then I want to seemingly unrelated model, stuff like that. How?
Yeah, so it's based on the function you have selected. Like I mentioned, if you want to run, you run analysis based on the function. All right. For example, now let me share this again. So if you look at this, my notes, you will see that when I want to run, sorry, let me go up a bit. So you will see that when I want to run percentages or make it generate percentages, I use the prop table. All right. So if I want to run scattered plot, I use GG scatter. So what I'm trying to say is that every analysis has a function. Once you know that function, yes, every analysis has its own function. So what I have done here is like, these things you can't like, Arrow has more than 10,000 packages. You can't know all of them. So I have tried to select the ones that maybe we use on a, so
and go by.
once you put the function and you load your data and the instruction you want to give, it will run that particular analysis that you need. Sorry, let me.
Okay, thank you, sir.
Yeah, so the analysis you run is tied to the function. All right. So once it's just for you now to be able to know which package you would use for that particular analysis and what is the function. Then you can put it, select the data and run it. Yeah. So, but you can actually, so I'm not able to teach you everything, but if there's a particular analysis you want to run and you're not seeing the package and you're not able to figure out the function, please reach out to me. I can get the function, I can get the package for you, get the function for you, and probably maybe do a short video on how to run it, if that will help. Is that okay?
Okay. Yeah, good evening, sir.
All right, good evening.
So,
yeah.
Thank you for this professorial detailed analysis you have provided this night. And before, when I hear R, I see it as something that is not being able, will I be able to learn it? And this approach you have provided as form of introduction to R, as make it to appear more simpler and becoming more friendly, and I'm becoming more interested in learning it more. unlike the
Exactly.
perception about it. So I really appreciate that. Oga Felix, I've been following you over time, and I really wish to meet you in person one day, sha.
Thank you.
So I
Thank
really
you.
appreciate your effort.
Thank
So
you.
somebody
You
is
are really
asking,
amazing.
yeah, somebody is asking a question that, okay, how do we export this to I'm writing my data analysis now. So I have to write my narrative.
No, you copy. It's a
Copy and
text.
paste.
Yes, it's a
Okay.
text file, but you know that.
Okay.
Let me show us something. See.
Mm.
Look at, sorry. Okay, just a second. Let me show us something, please. Before we go, because this thing is very, very important. I'm trying to open an analysis table. So let me share my screen and show you something. So look at this analysis table. Look at this analysis table. You see how this table is now. This table is totally different from this table. Are you seeing it? This table. You see these values here now. This is the same as this.
Okay.
But what did I do? Yeah, but what did I do? I moved the values. So you have to create your own table. Copying analysis output and pasting it. Even SPSS is not even allowed. Copying SPSS out, any analysis output is not allowed. You can create this table. It's very easy to create. And you say how? All you need to do is, let me show you how I created this table. If you want to print this now, this is how it looks. If I remove the grid, sorry, if I remove the grid lines, this is the way it looks. This looks nice, Abby. Yeah. But this table is easy to create. How did I create this table? Is easy. So I have 3 columns. I come here, insert 1, 2, 3. That's all. Or I can add more if I want. 1, 2, 3, and I scroll more. Right? So I can bring this closer. Bring this closer and bring this closer. So how do I make this table look like this? You highlight everything. Leave the grid line so that you will know what you're doing. So you come here and choose no border first. Then you highlight this first row. Come here, choose bottom border and top border. So you choose bottom border first. Then you choose top border first. Then you can now come down here and choose bottom border. That's it. So if I highlight this now and remove the grid line, this is what you see. This is the way your table looks. Then you can add the variable names if you want, variables. Then you add the frequency. Then you add the percents, right? So the point I'm making is, this is what the analysis will give you because it's a programming software. It looks like text. So you move your values from here and put it in a beautiful table because you are not allowed to copy the analysis output and paste. I hope this helps. Yeah. Thank you.
Thank you, sir.
Okay.
Yes, sir. I have a question. Good evening, sir.
Good evening.
My question is, can we use R programming for cleaning of data set and then to normalize it also?
Yes, you can use arrow data for cleaning. It's called data wrangling, but that one is a whole different. I don't know if I've done a lecture on data wrangling, but if you send me a message, I will check All right, and I will be able to share something. They call it data wrangling. Yes, you can use Arrow to do cleaning, but it's not straightforward. It's actually a very complex process, but it can be learned. It's after you have cleaned the data, you can now do normality, but you have to appreciate the fact that normality has nothing to do with cleaning of data. There are two different things. Cleaning of data is simply to help your data to run very well in terms of, like, let's say for example now, if you enter a data and maybe you wrote marital status, you wrote married with capital M starting it. Then you now write another married with small letter m. When you analyze it, the software, the statistical software is not very intelligent like that. It will tell you you have married with capital letter 1. You have married with small letter 1. It is only you that know that married with capital letter, married with small letter, both of them means married. That's where data cleaning comes in. So you have to harmonize all the married, ensure that the letters are the same so that it will analyze it as one, value. But normality means to check whether normality has to do with how you collected the data. If you collected the data using probability sampling method, or you just did confidence sampling, anybody that can feel. So you find out that the data will be favoring one group of people more than the other. So in that case, the data is skewed, so these are two different things. And I showed you how to check whether a continuous value, because normality is only for continuous data. All right, whether your data is normally distributed or not, if it's categorical, you're going to use frequency and percentages. It doesn't matter. But if your data is skewed, you're going to use median if it's continuous, or if it's normally, then mean. So I showed you how to check normality using Shapiro-Wilk. Yeah, I hope I answered your question. So can I take one more because of our time so that we can wrap up? Is it Bernard? Bernard?
Hello,
Hello, good
Bernard.
evening,
Yeah,
sir.
yes.
Yes,
Okay,
Yes,
Bernard is talking. Bernard
okay,
is talking,
Bernard.
please.
After Bernard Ibrahim, then we
thank you.
can wrap up. Yeah. Okay, Bernard, go ahead. Yeah.
Say, I'm a novice with statistics
Okay.
and then data, and then
All right.
especially with R.
Okay.
Today is my first time joining
Mm.
this, and I am very happy for the lecture you have given us. But I want to know, after the 5 days, what options do you have for somebody like me who wants to learn R
Okay.
to
So
the latter part, so that in my analysis I can do it myself?
yeah, it's not a problem. So what will happen is that after the lecture, I will introduce you guys. There's a Rising Scholar Data Science Hub we run. I know most people that are here are also there, are also members. So you will join the Rising Scholars, because in the Rising Scholars Data Science Hub, we run regular trainings. We run trainings I've done several trainings, and I have a list of webinars of the trainings I've done, which I can share with you as well, which can also build. So that's where you would find mentoring we do. Yeah. So hopefully after the 5 days, I would send everybody the WhatsApp link to join. All right. So that you can also grow with us. Yes.
I was asking if
Thank
you
you.
could have a Telegram, because for Telegram, we can have a permanent information on it, and then the size too can also hold for the
Yeah.
the
So the
data
thing
that you
is,
sent to us.
yeah. So the thing is, a lot of people are not very like me. I have a Telegram this thing. I mean I can count the number of times I go there. So Telegram is good, but people are not very, people don't visit it very much. So we can still use the WhatsApp. If we'll overshoot, then we can move to Telegram. All right. But it would be nice
I'm
that
grateful.
you join. Yeah, it would be nice that you join because even after this training now, I would run some other trainings, and that's where I usually advertise it, in that data science hub. Yeah. So yeah, it would be nice
Thank you.
that you guys join. Yeah. So what I can do before we wrap up, please, could you just stay let me post the invites. So for those that are here now, you can quickly join. You can quickly join. So I'm putting it now. So just copy it before you leave. I'm putting it in the chat. Just copy the WhatsApp link now before you leave. So that is the link to actually join. Yeah. So Dr. Chinedu, please ask
Thank you,
your
sir.
questions. Yeah, so that we can actually wrap up. Oh, this is 9. This is almost like 3 hours. Yeah.
Of course, yes. Thank you
Okay,
very much, sir.
sorry.
We are
Good
really appreciating
evening.
the program. So, good evening, sir. It's Ibrahim
Yeah.
that is talking, please.
Okay,
You allow
okay,
me.
Ibrahim.
Good
Okay,
evening.
Ibrahim. Okay,
Yes, yes.
Dr. Chinedu, just hold on briefly. After Ibrahim, I will take you then we wrap up. All right. Go ahead, Ibrahim. Yeah.
Thank you very much. We really appreciate and enjoy the program, and we are so happy. Thank you for the wonderful job, sir.
Thank you.
Mine is just to ask for the clarification regarding the use of some symbols in the table that you display. I think is the last thing you display. Assuming where you write the variables, the area where you write percentage and frequency and the percentage. Can somebody use n, since you have already wrote n outside the box? Then you write n to represent, and the
Okay.
percentage as a symbol. Is it acceptable?
Yeah. So the thing is, I know I get what you mean. Sometimes people do like this. It's also acceptable. Sorry, this.
Waiting.
Instead of frequency, you will do. Oh, why is this? Oh, this. Don't be wasting my time. So instead of frequency, you do n. Abi?
N, yes.
Instead of
Yes, yes.
percent, you do like this, isn't it?
Yes, yes, sir. Yes.
It's still allowed. You can actually do it. Yes,
All
it's
right.
still allowed. Yeah, but it's just that if you're going to do like this, I would prefer you do frequency like this, then you do your n like this, then you do your percent do like this. But if you prefer to just put n here, then I would recommend you do a
Yes.
key under.
All
Then
right.
yes, then
All
say
right.
this. Yeah, this means frequency or counts,
All
so that people will know what that n means.
right. Thank you very much, sir. I really
No worries.
appreciate it.
No worries. Thank you. Dr. Chinedu, let's wrap up with you.
Yeah, good evening, Prof.
Yes,
I always
yes,
call
good
you
evening.
Prof.
Yeah, good
Yeah,
evening.
thank you so much for this insightful teaching. I used to be scared of R, but the way you dealt on it today, it was so amazing. My question is this: is there a minimum or maximum size of data one can analyze? Because in my field, at times you might not have that large data, like you said during your PhD. You have a large data size. So I don't know if there's a particular minimum or maximum one can go for data size using
For
R.
no, arrow does not have minimum or maximum. Anyone
Okay.
would work, but it's just that when you arrow the whole, okay, let me just tell you this. How I stumbled into arrow, something just happened, and I was my office had this project, and we were collecting community sample to do a needs assessment project for a company, and the questionnaire was like 5,000, and each of that questionnaire was like 15-page questionnaire, 5,000. And after the data entry, it became very difficult to analyze it using traditional softwares because the data was so large That's how I now started reading, wondering, and this was like 2000 and I don't know, maybe over 10 years ago. I started reading when it comes to large data, that's how I stumbled on Arrow. I now realized that Arrow can deal with large data. So the plus of Arrow is actually the large data. If the data is small, yes, you can use Arrow, it's fine. But where Arrow becomes like that, my data I'm telling you now, which is over 1 million, I mean, I can comfortably use Arrow to analyze it because Arrow is known for dealing with big data. You understand?
Okay.
Yeah.
Okay.
But if you have regular data, it's fine. You can still use it. It's okay.
All right. Okay. Thank you so much. I appreciate
All
it.
right. Yeah.
Thank you, sir.